from a whole brain, it's just so hard to see the parts of the brain because the telencephalon, the cerebral cortex, is really hogging the view. All we really can see is the cerebral cortex. So what we're going to do is look at brains that are cut down the middle. This is the mid-sagittal cut, and we're going to look at the medial surface. And when we do that, here's a mid-sagittally cut left half of the brain. You can see, we're just going to remind ourselves of some things that we've already seen, just because I think a little bit of repetition helps things sink in. So this membrane here, this is the arachnoid. This is the left cerebral hemisphere. Down here we have the cerebellum. Between the cerebral hemisphere and the cerebellum, right here there's the space, and what's in that space? The tentorium, that fold of dura. It sits right there. So now let's look. The foramen magnum is going to sit like that. The foramen magnum is going to sit like that. So this is spinal cord, and this is now brain. The whole thing is brain. This piece, as we go around like this, oops, here, like that is all hindbrain. And there are three parts to the hindbrain. There's the cerebellum, there's the pons, and there's the medulla. In front of the pons, and then in front of the hindbrain is this structure right here, which is the midbrain. Now this brain was cut just off center, and I know that for a few reasons. One reason I know it is because there's a channel right here, and that channel is very narrow, and it's right on the midline. And so my probe is in that channel, but the cut is not there. So we're going to move over to this. This is actually from a different brain. And you see here, once again, the medulla, the pons, the cerebellum, and this piece right here is midbrain. And the midbrain is marked by this narrow little channel called an aqueduct. Okay, so that's an aqueduct, the cerebral aqueduct. This is the midbrain. Remember, we talked about the two colliculi, the superior colliculus and the inferior colliculus. The superior colliculus is important for orienting movements. If a bird flies by, you look at it. If somebody taps you on your shoulder and you look at them, you use your superior colliculus. And as a result of this superior colliculus, you can have something called blind sight, where you can follow moving objects. Your eyes will follow moving objects, but you cannot actually perceive them. Because the information doesn't get to your neocortex, no perception occurs, but you're able to follow them using your brainstem, using your midbrain superior colliculus. Okay, in front of the midbrain is this area, which is the thalamus. And the thalamus is this area right here. There's a little divide here. The bottom half of the thalamus is, or the bottom half of the diencephalon is the hypothalamus, and then up here is the thalamus. This structure right here, this is the corpus callosum. The highway that is connecting the right hemisphere to the left hemisphere. So through here, there are neurons that start, say, right here in the right hemisphere. They go down through the corpus callosum, and they end up in the analogous place in the left hemisphere. So it's just joining the two hemispheres. This is cut in cases of generalized seizures, where a person has a seizure that starts on one side of the body and goes to the other side of the body. If these don't respond to drugs, and if they're otherwise intractable, then sometimes the surgeon will come in here and cut the corpus callosum. Remarkably and interestingly, you actually have to do fancy tests to actually see that there's a problem, that the corpus callosum has been cut. Normally, you would never know it if you met somebody with a cut corpus callosum. Okay, so let's just go over the areas again. This is all telencephalon. Down here is diencephalon. This piece right here is midbrain. Here is pons, cerebellum, and medulla. These three make up the hindbrain, and here is the spinal cord.